Hey PCH, so in order to get us ready for our lesson tomorrow over solving polynomials, we need to do a little bit of pre-work to get us prepared. And that pre-work, as you can see by the label at the top of our screen, is we need to talk about and understand how to do polynomial division in order to set us up well for tomorrow. And so as a warm-up, we're going to focus first on multiplying polynomials because that's something I feel confident that we know how to do. And so if I'm looking at number 10, we are multiplying these two binomials together. If I use my area model to help organize my work, I'm going to put one of my factors, we'll do 8x minus 8 along one side of my area model, and then I'll put my other factor, 4x plus 1, on the other side of my area model. When I fill that out, when I multiply each of these boxes together, I get what you see in pink in my box. And when I go ahead and pull those terms out, I get 32x squared plus 8x minus 32x minus 8. And of course, my last step, as we know, is we see we have like terms, and so we need to combine those. And when I do that, I get 32x squared minus 24x minus 8. Now, what is that equivalent to? Again, we got that by multiplying 8x minus 8 times 4x plus 1. Two factors, 1, 2, being multiplied together to get us this polynomial. We can use this same process to multiply any size polynomials. It doesn't just have to be a binomial times a binomial, right? If we're looking at number 14, we can multiply this trinomial. Again, it's a trinomial because it has 3 terms times this binomial. And I'm going to go ahead and have you set up your area model for this problem in your notes right now. All right, team, when you set it up with your factors lining the sides of this rectangle, it should look something like mine. And now we're going to go ahead and fill in our boxes as well. I'll go ahead and do this first one, and then I'll let you do the rest on your own. So 3n times 6n squared is going to be 18n cubed. All right, you try the rest on your own. You can check it with my work in a second. And when you multiply everything together, complete your area model, pull those terms out, combine any like terms, you should get what I have here at the bottom. And again, I want to remind us how we got to this place, this 18n cubed minus 3n squared plus 23n minus 8, is by multiplying 6n squared plus n plus 8 times 3n minus 1. Right? One factor times another gives us this long polynomial. What we're going to talk about now is say, hey, what if we are given a long polynomial? We are given a factor, and we are asked to decide hey, we need to come up with this guy here. We're going to be able to use the area model and the thinking that we just did to work our way backwards to get this kind of factor. And so let's go ahead and move on to an example. We'll keep this one simple to begin. We want to reverse the area method of multiplication to find this quotient. What times x minus 2 will give us 2x squared plus x minus 10? Well, the first thing I'm going to do is draw my area model. I know one factor, and that's x minus 2. I'm going to throw that here on one side of my area model. I don't know what this factor is going to be, right? That's what we're trying to solve for right now. And so I don't know how many columns I'm going to need for this, but I just left myself plenty of space. What I do know is that what's going to be in this first box is 2x squared, right? The first term of our long polynomial that we got as our response came from this top left box because we're multiplying the first terms of my factors together. And so using that thinking, if I put my 2x squared there, so I've got that taken care of, I need to think what times x will give me 2x squared. and that is going to be 2x. Again, because 2x times x equals 2x squared. We're just working backwards. Well, now that I have my 2x here, I can do what I normally do and decide what's going to be in this bottom left box here. So 2x times negative 2 gives me negative 4x. And now I can work with my x terms. When I am multiplying these factors together, and I get my x terms in my area model, I am adding them together in order to get like this plus x, right? When we combine our like terms, we should end up with plus 1x. And so my thinking now needs to be negative 4x plus what will get me to a positive 1x? That is going to be a positive 5x. Again, because 5x minus 4x, when we combine those like terms, get us to this positive 1x. And so since that's taken care of inside of my area model, I'm going to cross that out because I don't need any more x's. I've got my like terms that are going to get me to plus 1x. Now I can continue as well. What times x will give me 5x? That's just going to be plus 5. And then lastly, 5 times negative 2 is going to give me a negative 10, which is perfect because I have a negative 10 that I need in my resulting polynomial. And so this is perfect. If I get a negative 10 here, that means I do not have a remainder. And so if I'm thinking about what the answer is to this question we were doing, 2x squared plus x minus 10 divided by x minus 2, that is equal to 2x plus 5. It is equal to this factor that we have here on our area model. Let's go ahead and try another example that's a little bit more complicated. So again, example 2. Take a second to write this down. We are supposed to find the quotient of x to the 4th plus 4x cubed plus 3x squared plus 4x plus 2. Wow, that's a crazy polynomial there, divided by x squared plus 1. Again, my first step is to draw my area model. Draw my area model. I'm going to throw my factor that I do know on one side of my area model, so x squared plus 1. It's going to give me 2 rows. And I want you to tell me what is going to go in this top left box. Hopefully you're able to tell me that x to the 4th is going to go in this top right box because it's the first term in our polynomial here. And so because we have x to the 4th here, we don't have to do anything else with our x to the 4th. I'm going to cross it out. What times x squared equals x to the 4th? That is x squared. Now we can fill out this bottom left box. X squared times positive 1 is just x squared. All right, we have our x squared in our box, but we want to keep going with the order that we see our terms here. And so even though we have an x squared, I'm going to focus on my 4x cubed. And so in order to get 4x cubed, I need to add 4x cubed because I don't have any x cubes right now. So I need to literally put 4x cubed. Now that's taken care of. I have all my x cubed inside my area model. What times x squared gives me 4x cubed? It's going to be plus 4x. 4x times x squared is 4x cubed. 4x times 1 is just 4x. Okay? Now we're down to our squared terms. So if I'm trying to get a 3x squared, and I already have a 1x squared, I'm going to add 2x squared, and that'll get me to that 3x squared. Because again, we are combining these like terms. 2x squared plus 1x squared is going to get me to 3x squared that I have here. What times x squared gives me 2x squared? That's just going to be plus 2. 2 times 1 is 2. And we see that if we're focused on our 4x's, we already have 4x in our area model. So we are perfect there. Same thing with our 2. We have 2 in our area model already. That has been taken care of. And so if we were thinking about what the quotient is, it is going to be x squared plus 4x plus 2, this factor that we just came up with at the top of our area model. Okay, I'm going to have you guys go ahead and try one on your own. This looks complicated, but again, we are doing the exact same process. Here. Let's go ahead and just start with setting up our area model. All right, should look something like this, putting that factor on the outside of my area model so I can fill in this first term. What is my first term going to be in this top left box? That's right, always starting with the first term in our long polynomial here, 3x to the 5th. And now we can continue. I'm going to have you finish the area model now and then check with my work when you are finished. See if you can come up with the quotient for this problem here. All right, let's see how we did. If you did your like this process correctly, you should have gotten the factor that I have gotten here. And we're going to keep doing this practice. This is like difficult stuff when we're doing it for the first time, but once you do more practice, you'll get the hang of it. One more type of example I want to talk about is, what if what we're dividing by isn't actually a factor of our original like polynomial and we have a remainder? I went ahead and already completed a lot of the area model for this problem, but what I notice is once I get to the point where my factor that I'm coming up with is like at the constant, right? I have a -4 here. I notice that where I'm supposed to have -2x, I don't have -2x, right? -12x and plus 6x, I'm at -6x. And so anything else that's after my constant, that's going to be considered part of my remainder. And so how am I going to get to -2x? Well, if I'm at -6x as it is, I need to add 4x to get me to -2x. Right? 6x minus 12x is -6x, plus 4x is -2x. Same thing with my positive 12. Right now I'm just at a -8. How am I going to get to a positive 12? Well, I'm going to add 20. That'll get me to that positive 12. Again, anything in this column, like I said, is going to be part of our remainder. And so if we have our factor here, x squared plus 3x minus 4, when we are adding the remainder, we're going to add everything in this column, so 4x plus 20, and we are going to divide that by whatever we are dividing our original polynomial by, x squared plus 3x plus 2. And so when we are doing this division here, our final answer, just to write it again one more time a little bit neater, is x squared plus 3x minus 4 plus our remainder, which is 4x plus 20 all over x squared plus 3x plus 2. And that is how we do polynomial division using the area model, as well as like when we have a situation where we have a remainder. All right, we'll see you guys tomorrow for solving polynomials.